that I felt a lecture just devoted to those individuals themselves would be warranted. Among those listed there in your text are Kepler and Galileo. We've got Francis Bacon, Descartes, Spinoza, Pascal, John Locke, and of course none other than Sir Isaac Newton himself. And these are, like I said, some pretty powerful figures. And so to start with Kepler, he was a German astronomer named, his first name is Johannes Kepler. Some people you might have heard him referred to as Johann or John Kepler, but he lived 1571 to 1630. He was one of the chief founders of modern astronomy because of his discovery of three basic laws underlying the motion of planets. Johannes Kepler was born December 27th, 1571, in the Swabian town of Weil. His father, Heinrich Kepler, was a mercenary. Although a Protestant, he enlisted in the troops of the Duke of Alba, fighting the reformed insurgents in the Low Countries. Kepler's grandmother brought him up for years, and he was actually a sickly child. In fact, it's pretty interesting how most of these great people struggled with sickness. I don't know. I just think that's interesting. I think everybody struggled with sickness, but, so if everybody struggles with sickness and then some of those people turn out to be major intellectual contributors, it's just sort of the name of the game, I guess. But at 13, he was accepted to the theological seminary at Heidelberg. Kepler wanted to become a theologian, and following his graduation from the University of Tübingen as a Bachelor of Arts in 1591, he enrolled in its theological faculty. However, Kepler began to excel in mathematics, science, astronomy, and physics. So that's what we know him for. We don't know him necessarily as a theologian. Important for astronomy was the idea that seized Kepler on July 9th, 1595. It appeared to him that the respective radii of the orbits of the planets corresponded to the links determined by a specific sequence in which the five regular solids were placed within one another, with a sphere separating each solid from the other. The sphere, or the orbit of Saturn, enveloped a cube, which in turn enveloped another sphere, the orbit of Jupiter. This circumscribed a trahedron, a sphere, the orbit of Mars, and a dodecahedron, a sphere, the orbit of Earth, and icosahedron. I don't know, I've never even gone that high on the hedrons, but icosahedron, a sphere, the orbit of Venus, and an octahedron, and the smallest sphere, the orbit of Mercury. The idea was the main theme. This idea here was the main theme of what was called Mysterium Cosmographicum, which he published in 1596. So again, Kepler's three laws that he's most famous for is, number one, the orbit of any smaller body about a large body is always an ellipse, with the center of mass of the large body as one of the two foci. The second law is the orbit of the smaller body sweeps out equal areas in equal time. And the third law is the square of the period of revolution of the smaller body about a large body equals a constant multiplied by the third power of the semi-major axis of the orbital ellipse. Now, I know that that's complicated. So really, if you needed to know anything, just know Kepler's three laws. Necessarily, probably don't need to know the square of the period of revolution of the smaller body and all that. But there you go. Those are the three laws. So Johannes Kepler was one of the key figures of the scientific revolution. True, he is not as well known as Galileo or the reclusive genius Isaac Newton, who built on Kepler's work, but Kepler, Germany's mathematical genius, was a major player in astronomy's history and set the stage for many subsequent important discoveries. By describing the process of human vision, Kepler wrote the first modern book of optics, Astronomiae Pars Optica, more Latin. He discovered the inverse square law of light, the foundation for measuring all modern stellar and galactic distances. His thoughts on the shapes of snowflakes resulted in the first book on crystallography, De Nive Sexangula. After Galileo's telescopic discoveries in 1610, Kepler described how the revolutionary new instrument worked. He also introduced improvements, including one that increased the field of view. His design came into wide use by the middle of the 17th century. We know Kepler mostly for his three planetary laws, which he derived after a Herculean battle with the data of the great Danish naked eye observer, Tycho Brahe. Kepler linked physics and astronomy by establishing the idea that the planets had to move due to unseen forces. He thus founded celestial mechanics and opened the door for Newton's work on gravitation. Then there's Galileo. The Italian scientist Galileo Galilei, 1564 to 1642, is renowned for his epoch-making contributions to astronomy, physics, and scientific philosophy. Galileo was born in Pisa on February 15, 1564. He was the first child of Vincenzo Galilei, a merchant and musician and abrasive champion of advanced musical theories of the day. The family moved to Florence in 1574, and that year Galileo started his formal education in the nearby monastery of Vallombrosa. 7 years later, he matriculated as a student of medicine at the University of Pisa. In 1583, while Galileo was home on vacation, he began to study mathematics and the physical sciences. Galileo's new interest brought to an end his medical studies, but in Pisa at the time there was only one notable science teacher, and that was a person by the name of Francisco Buonamico, and he was an Aristotelian, which means he had a particular view of the order of the universe, which it's kind of complex to go into detail about, but Aristotle, way back when, 1,500 years or more or whatever before this time period, had developed a order of the universe, dealing with so many levels of heaven, dealing with where the earth is at the center, and anyway, so we know Earth's not at the center. We'll actually discuss some of that here as we go. But Galileo seems, however, to have been an eager disciple of this great notable science teacher. And he paraphrases a lot of Aristotelian physics and cosmology. So, some of his notable contributions, Galileo's astronomical observations with a telescope provide proof that the Earth is not the center of the universe, is one of the contributions of Galileo. Galileo is credited with establishing the modern experimental method. Before Galileo, knowledge of the physical world advanced by scientists and thinkers was, for the most part of a matter of hypothesis, untested ideas and guesses. In contrast, Galileo introduced the practice of proving or disproving a scientific theory by conducting tests and observing the results. His desire to increase the precision of his observations led him to develop a number of inventions and make numerous discoveries, particularly in the fields of physics and astronomy. Another invention of Galileo was the hydrostatic balance. He returned to Florence in 1585, having studied the works of the Greek mathematician Euclid, who lived in the 3rd century BC, and the Greek mathematician Archimedes, who was in about 200 or 300 years before Christ. He expanded on Archimedes' work in hydrostatics, a branch of physics that deals with the amount of pressure in fluids. He creates this hydrostatic balance, which was a device that was designed to measure density or mass of objects by weighing them in water. Now, it may not mean much to us, but this was a big deal. The following year, he published an essay describing his new invention, which earned him a reputation throughout Italy as a talented scientist. Other contributions that Galileo made, we have he develops the early thermometer, He discovers the law of uniform acceleration, which later helped English mathematician and physicist Isaac Newton derive the law of gravity. By observing a supernova in the sky in 1604, he was led to reason that the object was farther away than the planets, and pointed out that this violent event in the sky meant that the perfect and unchanging heavens that Aristotle talks about in his work is actually not part of this unchanging atmosphere or unchanging heavens, and that in order for this event to have happened out there in space would be an example of change, and that would go against what the Aristotelian cosmology would say, that the heavens are unchanging. Galileo modified the 3x magnification telescope up to a 9x magnification, and then later on he gets the telescope up to 30 times magnification, and he publishes those discoveries that he makes with this telescope in March 1610 in a book entitled The Starry Messenger. This book increased Galileo's fame significantly, and his discoveries, though questioned by some, were praised by many scientists, including the German astronomer Johannes Kepler that we just talked about. Accredited to Galileo is that he discovered that 4 moons rotated around Jupiter, and he calculated the length of time it took each moon to circle the planet. In 1624, Galileo goes to Rome, and he asks Pope Urban VIII to revise the church's position on cosmology, because the church believed that the earth was the center of the universe. So they agree to let him write the Copernicus theory, which is that the sun, of course, is the center of the universe. But they tell him that in the work that he must favor the church's model over the Copernican model. So the church approves his endeavor, but it ends up that he doesn't follow the agreement, and he finds himself before the Inquisition. And he's actually found guilty at the Inquisition, and he is made to recant his position, which he does against his conscience. And then we have Francis Bacon. Now, Francis Bacon was an English philosopher and a statesman and an author. Now, he lived 1561 to 1626, and he was the chief figure of the English Renaissance. His advocacy of active science influenced the culture of the English-speaking world. Francis Bacon was born in London on January 22nd, 1561. Bacon entered Trinity College, Cambridge, in April 1573, and he completed his studies there in December 1575. He began to study law at Gray's Inn, but his studies were interrupted for 2.5 years while he served with Sir Amyas Paulet, the English ambassador to France. Upon his father's death, Bacon returned to England, re-entered Gray's Inn, and became a barrister in June 1592. Bacon developed a dislike for Aristotelian philosophy at Trinity College, and he also opposed Platonism. He felt that Aristotle's system was more suited to disputation than to discovery of new truth, and that Plato's doctrine of the innate knowledge turned the mind inward upon itself, away from observation and away from things. Bacon's new method emphasized the commerce of the mind of things. Science was to be experimental, to take note of how human activity produces changes in things, and not merely to record what happens independently of what men do. This is part of what Bacon means by active science. Still more fundamental is an ethical component. Science should be a practical instrument for better human betterment, for the betterment of humankind. Bacon's attitude is best summed up in a passage from Plan of the Work, in the great Instauration, describing the 6th part on the new philosophy or active science. Man is the helper and interpreter of nature. He can only act and understand insofar as by working upon her he has come to perceive her order. Beyond this, he has neither knowledge nor power, for there is no strength that can break the causal chain. Accordingly, these twin goals, human science and human power, come in the end to one. To be ignorant of causes is to be frustrated in action. Bacon had already developed a literary reputation. He had also penned a number of masques for royal entertainment. In 1597, he had published a collection of essays on various topics, from gardening to the nature of good and evil. In 1605, he published The Advancement of Learning, a new categorization of the whole of the natural sciences. He continued this theme with Novum Organum in 1620, which outlined a new method of natural philosophy to replace Aristotle. Bacon proposed that, through his method of induction, the secrets of the universe could be unlocked and used to benefit society. His method involved the unbiased, almost random collection of data, which would later be generalized into rules of nature. Bacon's method never became popular, but many of his other ideas proved influential. In The New Atlantis, 1626, he described an imaginary society of scientists which had a profound effect on many of those who founded the British Royal Society. And then we have René Descartes, who was born in 1596 in France, died 1650 in Sweden. He was French, and he was a philosopher. The French thinker René Descartes is called the father of modern philosophy. He initiated the movement generally termed rationalism, and his discourse on method and meditations defined the basic problems of philosophy for at least a century. To appreciate the novelty of the thought of René Descartes, one must understand what modern philosophy or rationalism means in contrast to medieval or scholastic philosophy. The great European thinkers of the 9th to 14th century were not incapable of logical reasoning, but they differed in philosophic interests and aims from the rationalists. Just as the moderns from Descartes on usually identified philosophy with the natural and pure sciences, so the medievals made little distinction between philosophical and theological concerns. The medieval doctors like St. Thomas Aquinas wanted to demonstrate that the revelations of faith and the dictates of reason were not incompatible. Their universe was that outlined by Aristotle in his Physics, a universe in which everything was ordered and classified according to the end that it served. During the Renaissance, however, men began exploring scientific alternatives to Aristotle's hierarchical universe. Further, new instruments, especially Galileo's telescope, added precision to scientific generalizations. By the beginning of the 17th century, the medieval tradition had lost its creative impetus, but the schoolmen, so-called because they dominated the European universities, continued to adhere dogmatically to the traditional philosophy because of its association with Catholic theology. The rationalists, however, persistently refused professorships in order to preserve their intellectual integrity or to avoid persecution. They rejected the medieval practice of composing commentaries on standard works in favor of writing original, usually anonymous, treatises on topics suggested by their own scientific or speculative interests. Thus, the contrast is between a moribund tradition of professorial disputes over trivialities and a new philosophy inspired by original and scientific research. Descartes participated in this conflict between the scholastic and the rationalist approaches. He spent a great part of his intellectual effort, even to the extent of suppressing some of his writings, attempting to convince ecclesiastical authorities of the compatibility of the new science with theology and of its superiority as a foundation for philosophy. In 1637, when he was 41, he set the problem of how the human mind is related to the body. Now, this is the most important thing, which is a puzzle that has baffled Western philosophy and science ever since, known as the Cartesian mind-body problem. Today, it's at the head of the agenda of 21st century science. Do human beings have immortal souls, or are their minds merely their brains that rot when they die? How that question is resolved will have repercussions on humankind greater than an atom bomb. I mean, Descartes is one of those rare geniuses in human history, like Socrates, whose ideas dominate human thought for millennia. And then there is Spinoza. Baruch de Spinoza was born into the Jewish community of Amsterdam on November 24th, 1632. His parents were Jews who had fled, along with many others, from the vicious intolerance of the Inquisition to the limited and hesitant freedom of Holland. At the time Spinoza was born, the Jewish refugees had already established themselves to a certain extent in their new home of Amsterdam. The central element of the teachings of Benedict Spinoza, which is one of his other names, is substance. All existence is contained in one substance, which can be named differently, such as nature, universe, or God. We may understand it as consisting of two key attributes, objective and subjective. Spinoza believed in universal rules governing everything within the universe. In the material world, there is a hierarchy of objects, with God as an infinite and the highest substance. Human beings were part of nature and were the carriers of the two attributes, objective and subjective. The human mind corresponded to the world of material objects. Ideas and objects were two sides of the same substance, nature. Descartes is usually cited as the beginning of modern philosophy. Yet, with the possible exception of what Descartes said about physiology, most of his ideas have not been amenable to scientific analysis. For example, his mind-body dualism, his beliefs in free will and innate ideas, and the teleological basis of much of his theorizing. Spinoza should be given more credit than Descartes for influencing the development of modern psychology. Spinoza was perhaps the first modern thinker to view the world, including man, from a strictly deterministic standpoint. Both mind and body are of equal status, and both are subject to natural law. Spinoza saw clearly that his deterministic view of man required that there be laws of nature which are applicable to man. And then we have Blaise Pascal. Blaise Pascal was born June 19th, 1623, at Clermont-Ferrand, France. As a young man, his initial intellectual accomplishments were in the areas of mathematics and physics. In order to help his father compute tax revenues in 1639, he built a calculator. In 1640, he completed an important study on geometric conic sections, and leading to Pascal's, which eventually led to what we call Pascal's theorem. Between 1647 and 48, his work on vacuums and atmospheric pressure led to Pascal's law. At the end of 1654, after several months of intense depression, Pascal had a religious experience that altered his life. He entered the Jansenist monastery at Port Royal, although he did not take orders, and led a rigorously ascetic life until his death 8 years later. He never published in his own name again. The Jansenists encouraged him in his mathematical studies, which he resumed. To assist them in their struggles against the Jesuits, he wrote under a pseudonym, a defense of the famous Jansenist Antoine Arnauld, the famous Lettres Provinciales, provincial letters, in which he attacked the Jesuits for their attempts to reconcile 16th century naturalism with Orthodox Roman Catholicism. His most positive religious statement appeared posthumously. He died August 19, 1662. It was published in fragmentary form in 1670 as the Apology of the Christian Religion. In these fragments, which later were incorporated into his major work, he posed the alternatives of potential salvation and eternal damnation, with the implication that only by conversion to Jansenism could salvation be achieved. Pascal asserted that whether or not salvation was achieved, humanity's ultimate destiny is an afterlife belonging to a supernatural realm that can only be known intuitively. There is for Pascal a very simple answer to the problem of being human. We are wretched without God and happy with him, which is what he wrote in his Pensées. What could be more simple than that? Pascal's existential analysis of the profound need at the core of human life now finds its corresponding response in God's offer of redemption. Our salvation from our despair is not for Pascal a matter of abstract belief in a distant creator, but is rather a specific belief in the Christian God and the salvation offered by Jesus Christ. All the philosophical proofs and arguments of natural theology are, without Christ, useless and sterile to Pascal. John Locke, born August 29, 1632, in Rington, England, dies October 28, 1704, in Oates, England. He was a philosopher. The English philosopher and political theorist John Locke began the empiricist tradition and thus initiated the greatest age of British philosophy. He attempted to center philosophy on an analysis of the extent and capabilities of the human mind. John Locke was born, like we said, August 29, 1632, in Somerset, where his mother's family resided. She died during his infancy, and Locke was raised by his father, a small-town attorney. John was tutored at home because of his delicate health. He then went to Christ Church, Oxford, where in 1658 he was elected senior student and taught Greek and moral philosophy. He changed his subject to medicine and received a license to practice. Here Locke met Robert Boyle, the distinguished scientist and one of the founders of the Royal Society, and under Boyle's direction took up study of natural science. Finally, in 1668, Locke was made a Fellow of the Royal Society. None of Locke's major writings were published until he was nearly 60. In 1690, he brought out his major works, 2 treatises and the Essay Concerning Human Understanding. But the 4 books of the Essay collection were the culmination of 20 years of intellectual labor. The intention of Locke's essay was positive in that Locke wished to establish the dependence of all human knowledge upon everyday experience or sensation. The alternative theory of innate ideas he vigorously attacked. While it is true that John Locke was not one to hold on to beliefs or opinions that he thought improbably or false, it is equally true that some matters preoccupied him throughout life: science, medicine, philosophy, politics, and especially religion. More particularly in his fascination with Scripture, his unwillingness to readily dismiss or reject its teachings, and his desire to appropriate its message in his philosophical and political writings that make John Locke such a fascinating study for a biblicist. Interest in Scripture was not so unusual in 17th century England, but it was a little unusual in a founder of the Enlightenment, a rationalist movement that sought to do away with religion, superstition, the clerical establishment, and the privileged position of the Bible in society. A major influence on modern philosophical and political thought, John Locke optimized the faith of the Enlightenment in the middle class, the new science, and in human goodness. For a century, the English Whig Party was dominated by his ideas, and much of the liberal social, economic, and ethical theory of the 18th century was rooted in his theories of social contract. He influenced such later philosophers as David Hume and George Berkeley. Moreover, Locke greatly influenced Thomas Jefferson, who wrote the Declaration of Independence. For example, a quote from Locke's political philosophy states, "Life, liberty, and property whereas Jefferson in the Declaration of Independence says life, liberty, and the pursuit of happiness, clearly working within this political philosophy borrowed from John Locke. And lastly, we have Sir Isaac Newton. Born Christmas Day in 1642 in Woolsthorpe, England, dies March 20th, 1727 in Kensington, England. He was a physicist and he was English. By vigor of mind, almost divine, the motions and figures of the planets, the paths of comets, and the tides of the seas first demonstrated. This is what's attributed to Isaac Newton. Many considered Isaac Newton to be not only one of the greatest figures in the history of mathematics, but also one of the supreme intellects ever produced by the human race. Besides his explanation of the laws of motion and gravitation and his discoveries concerning light and color, his development of calculus is regarded as the greatest creation in all of mathematics. His quarrel with German mathematician and philosopher Gottfried Leibniz, 1646 to 1716, over calculus was one of the longest and most bitter scientific disputes. Now, I don't like math very much, so I couldn't imagine having a bitter dispute and quarrel over calculus. I couldn't imagine what that would be like. But anyway, so Isaac Newton formulated the theory of universal gravity. He was an inventor of calculus. He made major discoveries in optics. He has long been regarded as perhaps the greatest scientist and as one of the greatest mathematicians ever to have lived. More recently, philosophers have begun to appreciate the extent to which Newton's remarks on scientific method illuminate the seminal contribution he made, especially his Principia, to the transformation of natural philosophy into the physical sciences as we know them today. We know now also that Newton put at least as much effort into alchemy and theology as he did into his celebrated contributions to mathematics and science. Although Newton recognized disciplinary distinctions, ultimately for him there was no impermeable barriers between philosophy, physics, and faith. Because Newton was committed to the topos of the two books, namely that God had written both the book of nature and the book of Scripture, he believed that truth ultimately comes from the same divine source and thus is one. Consequently, Newton highlights moral and religious corollaries into the study of nature in the conclusion of his Optics text. And if natural philosophy in all its parts, by pursuing this method, shall at length be perfected, the bounds of moral philosophy will be also enlarged. For so far as we can know by natural philosophy what is the first cause, what power he has over us, and what benefits we receive from him, so far our duty towards him, as well as that towards one another, will appear to us by the light of nature. And that is found in his Optics. For Newton, advances in natural philosophy were completely bound up with moral and religious concerns. These in turn related to right method, a humble empiricism, whether in science or religion. Newton believed that the inductive method led to purity and truth. And there we have a look at the intellectual history of this period by discussing in closer detail Kepler, Francis Bacon, Galileo, Descartes, Pascal, Spinoza, John Locke,
and then moving along, we have Charles Darwin, who is a very fascinating character indeed, and quite the center of much controversy, to say the least, because of his theory of evolution and the tension that exists between creationism and evolution, which is an ongoing battle today. Charles Robert Darwin was born in 1809, and he lived until 1882. He was born in Shrewsbury, England. He was the son of a physician. As a naturalist, he won sponsors and government backing for an expedition on the military sailing ship, the HMS Beagle,
where he made his famous observations on the differences in finches on the island, the Galapagos Islands in South America. He later used all that information that he had gathered to support his theory of evolution. It should be noted that he was not the first to come up with a theory of evolution. There was some other scientists that had come up with these ideas. He wasn't alone in that, but he did, in fact, have the loudest voice. He's most famous for his work on the origin of species in 1859, in which he suggested in the last lines of the first edition that while this planet has gone cycling on according to the fixed law of gravity, therein life with its several powers have been originally breathed by the Creator into a few forms, or into one from so simple a beginning, endless forms most beautiful and most wonderful have been and are being evolved. It's interesting because Darwin didn't shy away from that there was a God. And so, I think at the end of the day, we would consider him to be a kind of agnostic theist, necessarily leaning way far the other direction from organized religion. On page 520 of The Origin of Species, he also has a very interesting statement that he makes where he says outright, I see no good reason why the views given in this volume should shock the religious feelings of anyone. It is satisfactory, as showing how transient such impressions are, to remember that the greatest discovery ever made by man, namely the law of the attraction of gravity, was also attacked by, and he names a guy. But he goes on to say, a celebrated author and divine, someone that was popular in his day, went on to say that they had accepted the idea of evolution as a just and noble conception of the deity. To believe that God would create a few original forms capable of self-development in other and needful forms, as to believe that God required a fresh act of creation to supply the voids caused by the action of his laws. And so there's kind of this ongoing kind of woven into the text, this idea that God was, a real concept, that there was in fact a creator. And it wasn't necessarily, I guess Darwin's major point of contention would have been found in his disagreement with Christianity and his rejection of the Old Testament, and the criticism that it was not historical and things of that nature. And to this day, Darwin, when just to even say the name Darwin, invokes quite a bit of hostility at times in certain circles, and but we cannot deny that Darwin himself actually rejected Christianity. He rejected religion, and a lot of some scholars believe that was due to the fact that he lost his daughter, and that made him angry with God, and he made some commentary outside of course, his major work, The Origin of Species, but that was to the effect that he was giving up on this idea of God because he thought hell was unjust and things like that. And so I like to bring this topic up in this course because I think that any thoughtful human being should be able to look at this topic and at least be able to talk about it in a civil manner. And so we do, I try to bring one of the discussions for this course try to implement the discussion of, is it possible to believe in God and believe in evolution? And, I would say it would probably be impossible to be a biblical literalist, meaning you believe everything in the Bible is to be literally true, exactly what it says, and to be an evolutionist, unless you created some sort of, time-lapse theory that 7 days was 7 trillion years or something for God. That may be one way to reconcile it. But I would definitely say that his plan at the core, the fundamental principles of his theory are in opposition to the literal creation story in Genesis. However, Darwin did not reject that there might be or could be a God, and some people have even gone on to reconcile their belief in God and their belief in evolution. And of course, that's a decision you have to make as a human being. You might reject it all. Who knows? You might reject the whole God thing totally and say, who cares? It's none of my business, whatever. Not worried about it. You might think Darwin was crazy as well, whatever. But I like to, bring us this conversation up in discussion. It is important to acknowledge Darwin. We can't talk about the humanities. I mean, we cannot discuss history without acknowledging the key event that is Darwin's theory becoming popular. What he had to say about the origin of species was transformative. I mean, it changed the course of the world. I mean, it was a kind of reformation in thinking. I mean, if we thought that what took place in the 1500s concerning our understanding or humankind's understanding of the world, there's no way in the world we could even begin to neglect the way Darwin's theory changed the world, at least the way God was conceived, or even the human beings and the elevation of our status. And I think that's one of the main points of contention for creationists and theists and believers, or whatever you want to call them, is that if humankind is just one more species of mammal, some other animal, we're not any more elevated intellectually, or that we don't have a soul or anything greater than what we see on the surface in the material world, and we're just as comparable to the dog down the street or a horse. People could begin to say, I could see why people would find that problematic for their worldview, because they would want to believe that they're as human beings, they're important. That they're important because God created them and made them special and in His image. And so I totally can understand the argument for sure the creationists hold.